Karski.
Mike Heisey.
And we have a third member, Chris, but he has other commitments. He's actually out of state, out of New York. So we are on Make, and as a review, basically we're trying to do two things. One, tell you how complex your build system of Makefiles is, and all the intricacies that you can't see by glancing at 500 plus lines of make code or something, hundreds of lines. The second thing is to put it into an intermediate format where it can go to other build system formats, like CMake. I actually originally wanted to go straight to Visual Studio, but that's pretty stupid considering CMake can go to several things, actually, including Visual Studio. So this is just a diagram we used last time. One of the things about our design that's good, I hope, is that we've divided it up into pretty much completely separated subsystems. Now it's 3 totally separate subsystems: a parser, an analyzer, and a generator. CMake generator specifically. And the parser uses making very heavy use of an excellent open source library that does most of the grunt work. It actually parses a dump of make, doesn't actually parse the file itself line by line. The analyzer, Mike can talk more about that in a bit. And the generator, I'm trying to read an XML file that describes what the make file it analyzed and make a CMake file out of it. And yeah, those are all separate. The build format has seen some updates, good ones. We're slowly getting more and more information out of the make file that we started from. The new thing is that it'll carry over instructions now properly. The variables are substituted, which is bad. We're working on that because one of the things in this whole conversion process is you want to carry over as much information that the original designers made as possible. Otherwise, you'll get to a new build system and have to add all the variables again and whatnot. So yeah. And I've also been working on using a schema. These would be really helpful for 2 reasons. The first is to validate the output coming out of the parser. And it'll actually be really helpful in the development process because he can make a change that breaks the format, and we need to always have a schema that says whether or not it's still in the correct format. And the second thing it can do, in actually a variety of languages, but C# can use them to, I guess, generate objects from the schema versus a given XML file. So yeah, on that. And now Mike's going to talk more about improvements to the parser and analyzer.
All right. So on the parser side, we have a number of improvements that we've made since the last time. The first sort of big one was a bit of a cleanup thing, is that the parser was previously doing a lot of analysis on its own. This was sort of an artifact of the fact that the software was originally made. Well, we got our start of it last semester during SD&D, and for time reasons, we sort of, we're running out of time. So what do you do when you're running out of time and you're a computer scientist? Well, of course, you drink a lot of coffee and write a lot of material, and things work, but it's kind of messy. So we've separated the analysis out of the parser side now, so it's just doing parsing of the makefile using our sort of end run around using a library called makefile parser gmakedb, and generating a common build file, XML-based common build file format of that. Now we've also we've gotten some speed improvements on the parser. When I looked into it, after I had finished sort of farming out the analysis parts that it was doing, the sort of uncalled for intimacy between the 2 different submodules, I found that by limiting some other extraneous work I was doing internally before it switches over to XML using the XML library I'm using, we basically have a structure that represents the sort of DOM of the XML file, if you will, with basically a hash ref of hash refs in a sort of tree structure. And I found I was doing a lot of extraneous work, so we wound up getting about a 4x speed up of the parser just for free by removing extraneous work we were doing. And the big thing we've done is that we now run a pre-processing step on the makefile that basically goes through, finds the final value of different variables, and substitutes them in. And then we run a pre-processing phase, and then we run the parser on what we call it is a make simple, is the desugared make file. We run the parser on that, and then we're able, as you might have seen in the screenshot before, to propagate the final command string to build a certain rule from that. So the parser has seen a lot of improvement to get to version 0.4 of the common build format. And the analysis side is moving to. We updated it so that we can read the CBF version 0.4 and do analysis of it. Files and rules are now analyzed separately, so it doesn't just give you a count of rules, it also tells you how many total nodes you have in your build tree, which is perhaps a useful metric for various people. I also, when I was originally doing the analyzer, basically what it does to do its analysis for is it winds up doing I guess technically the explore algorithm, but more or less a depth first traversal of the build graph as it's generated. And when I looked into that, I found I was actually doing two passes on the whole thing. One to build the graph, and then another one to check to see whether the build graph was cyclic or not. And I was going to go through some work to remove that, and then I realized when I profiled it that for a typical project it might take 40 seconds to parse and analyze a large build tree. For instance, for Emacs it takes about that long. And when I profiled it, I found the analyzer took about 17 plus or minus 3 milliseconds of that 40 seconds. So I didn't actually bother doing that optimization. And as that sort of leans to, we've got some milestones. The last time we gave a presentation, I believe Morthy asked us when we were going to be able to do Gen 2. Well, we haven't been able to do that yet, but we have moved up. At that point, the only decent sized thing we could do was an old version of GNU tar before they switched over to recursive makefiles, which are much more difficult to analyze. At this point, we can do 3 decent sized projects. We can do the most recent version of Bash. We can parse and analyze correctly the most recent version of Vim 7.3 and the most recent version of Emacs 23.4 can all get parsed and analyzed. It's correct, and it generates an optimized build order for you. So that, I believe, is actually what we're going to demo for you today. All right, so here I am in a directory that for some reason has 3 different open source projects in it. So we're first going to go into Bash. And oh, look at all those files, wow. So we're going to run unmake on here. And that ran pretty quick actually because I forgot that I already had the CBF generated. So, oh no, that just ran really fast. All right. So Bash is small enough that it actually runs really fast on that. But as you might have seen, oh no, it was there. It did clean up on its own. But as you can sort of see at the top there, and as will come about again in about 20 seconds or so, give or take, we actually do generate. Ignore those warnings. Those are generated by one of the libraries we use for the pre-processing phase. So there's not a lot we can do. I submitted a patch on GitHub for one of the, here we go, for one of the problems with that library. It hasn't been merged yet, and I guess there's a little bit of confusion over whether the version on GitHub or the version on CPAM is the canonical one that they want to merge things to. But anyways, you can see that it generated a count of how many rules are in the build system, how many files, so that's including things that have implicit rules for them, or things like headers that are just leaf nodes. It tells you that it's acyclic, which is a good thing because, well, if your build system isn't a directed acyclic graph, you have other problems. And then from that, since it's acyclic, we can do essentially a post-order traversal and generate an optimal build order here. And you'll see that going from source files here, we eventually end up near the end generating the actual Bash executable and some other stuff that Bash likes to make, because in real projects you have to generate documentation and things like that. So that's Bash. Let's see something a little more, well, a little larger. All right. So Emacs. There's a lot of stuff in this tree. You can probably see that it scrolled off my screen. So, and I can't spell. So, I would say not to get a cup of coffee. This actually won't take that long, even though there's a bazillion files. It will generate a couple of warnings, but I forgot to pipe that to less, so it's going to scroll up the screen too. Make simple here. You see it spitting out a couple sort of trivial errors. Is what we call our pre-processing phase that desugars the make file. before we then actually parse and then analyze it. And oh, there we go. So it took 29 seconds, of which 12 were user and 1 were sys. So you'll notice it took about twice as long real time as we actually had CPU time. This is running in a VM, it doesn't get every cycle. On a regular machine, this would run even faster, and also if this wasn't a laptop from 2006, it would probably run a bit faster. So this here is the tail end of, let's see, can I actually scroll up and capture that? Unfortunately, no. All right, that's the tail end of the optimized build order that it gave us. You'll see Emacs is right there at the end, as it should be, because you should build all the subcomponents before you build the largest thing. If it hadn't scrolled off the top, you'll see this approximately 395 rules and about 440 files in the build system, and that ran pretty quickly. So I guess in terms of working on large things, we're not at the point quite yet where we can analyze the Linux kernel, but we can do some pretty large open source projects. In terms of future directions, Frank and I both have some time over the summer. Frank because his job doesn't start until August. Me because my job is located approximately 5.5 hours by car from where my girlfriend is, so I will have free time. So even though we're graduating, we hope to continue this project in the future. We think that it does have some promise to be a really useful thing because there are a lot of projects. KDE did this not too long ago that are looking to get out of make-based build systems and onto things that are more palatable to use, things that don't, summon Cthulhu from Riley and things like that. So, any questions?
Can you do Vim?
Actually.
So apparently there's a war going on, an editor war. I don't know who's on which side here.
Particulars.
There we go. Yes, we can do Vim. So, well, somebody else asked a question, I guess, while Vim is doing. Anybody? All right.
Actually, talk to these projects to see if they actually are interested in converting it, or are you just still kind of working on it?
We haven't talked to too many yet. I talked to Kitware a while back, who was Kitware. If you guys aren't aware, is the company that's sort of behind the open source project to CMake, and they contracted them to assist and help them automate their process of getting from Make to CMake, which occurred, I believe, KDE 4.1 was like 2-ish years ago. If anybody actually, does anybody in the world use KDE still? Excellent. I kid. Yeah, I think SUSE still uses it. It's its default. But so if you'll see, Vim has a somewhat fewer files than Emacs. 105 rules in the build system, 112 files. Build graph is acyclic. Vim is the second to last thing that's built. Anybody know what XXD is? Anybody have a guess?
Some style definition, is it?
Not exactly. XXD is actually a tool that Vim uses internally to auto-generate its man pages from some other documentation format. So that's why that gets built last. We do, I should say while we're here, we do a little bit of filtering on that build order list because, all is obviously not a real actual file that gets built, but it would normally be the last target. So it's probably never going to be possible to be intelligent enough to filter out everything that's not directly in the binary, but we can do a little bit. We also don't list anything there that doesn't have any dependencies. So you're never going to see header files in your build order because you don't actually need to build them because they're basically they're leaf nodes is what we're going to be filtering out for that.
You seem to print out all of the errors and warnings at the top, and then you print out a whole bunch of stuff after that.
Oh, all right. So the reason that is because the errors are coming out on std_err, and this is coming out on std_out.
Okay.
So that.
Because I know when I build a program, right, and it spits out a whole bunch of stuff after my warnings, I ignore the warnings.
Yeah. Well, the nice thing is that actually might be a good side effect because so far, number one, there's not really anything we can do about these warnings at this point. So, for instance, no rule to make target.c needed by suffixes ignored. That's a warning that's getting propagated through our preprocessing thing from make itself when it's generating its database dump of its internal state when it's trying to do the parsing. So
you can write a wrong make file and run make, and it'll do something.
Yeah.
Possibly the right thing.
And one thing we've learned while we've been trying to find interesting things to demo on is that almost every make file you find in the wild relies either on undocumented or not necessarily explicit behavior of make, usually of the GNU version of make, or with some things on BSDs, they rely on the System V version of make to behave in a certain way that isn't necessarily specified. So, and you'll also notice for Vim and Emacs, we're not running this analysis from the top level directory, we're running it from the source directory because both of them have sort of wrapper make files that, don't do a whole heck of a lot, and then like a real make file in the source directory that builds all the stuff. Once you get to this level of complexity where this sort of tool is useful, there's always going to be some sort of bespoke or custom quality to your build system. Nobody's going to just, plug things into auto tools and let it do its thing, unfortunately, for people trying to automate things. But you also notice that was all I had to do was switch into the correct directory. So we feel that it's enough of a win versus a manual conversion of a build system that would take months, that it's still worthwhile even if you have to tweak the input a little bit before it'll run. So, anybody else, Bueller?
What do you build on make with?
What do we build on make with? Oh, this is embarrassing.
Make files, right?
A non-recursive make file, actually.
Really nice.
Yeah. That's a funny thing. We generate a common build file format that our project generator could make a CMake list from for ourselves, and we actually maintain that in the repo, but we haven't switched over to the point where that's what's hosting it yet. So we are working on eating our own dog food. We aren't quite at that point yet. And it's funny because that's actually like one of the larger points of annoyance with this project, ironically, is updating the make file whenever we make a change and having to deal with make's abominable syntax. When we were trying to figure out an OpenGL demo that we just picked off the web that we could build. We were hoping to do a little demo of. And one of the things we found out was that the make file that was there that was built in, whoops. Anyways, the make file that was from that demo online, which was only written in like 2003 and worked fine then, no longer worked at all. Even though I don't think GNU make has changed substantially in the last 20 years, much less 9 years. And we took a long time to figure out the errors, and what it actually was that make doesn't really account for line endings. Well, it does account for them, and if you have the wrong line endings, it'll barf. If you guys don't know about the syntax of a make file, a line that doesn't either start on column 0 or after a hard tab character is a syntax error. So if it's expecting an LF or a CR as its line ending, and you have a CRLF or the other one, it'll just barf, and it'll spit out an error on that first line and not make anything. So there are a lot of reasons to come off this, but anyways, that's what the problem with the OpenGL example we found on the web was. Eventually, was that the guy had mixed line endings, and it was causing make to barf on it, and also that he had used soft tabs, so he had 4 spaces instead of tabs when he had saved the file in his editor, and that caused it was just
my machine.
Yeah, exactly. Yes, the Jeff Atwood seal of approval. But so, anybody else? All right, thank you very much. You've been a wonderful audience.